So now we're going to calculate an NPV. Here is the example. It is a stream of cash with a cost today in year zero of $3,000, and then we're expected to get $1,500 in year one, $1,800 in year two. So let's think about whether it's worth doing this project. In period zero, today, we need to spend $3,000. Is it worth it to spend that $3,000? What do we get in return? What are the cash flows coming in off the project? Well, we have a cash flow of $1,500 coming in at the end of year one, and we've got a cash flow of $1,800 coming in at the end of year two. If we just sum up those cash flows, it's a minus $3,000 because it's a cost, right? So there's a minus in front of that, plus the $1,500 coming in year one and the $1,800 coming in year two. If we add all those together, we get $3,000 minus $3,300, the $1,500 plus the $1,800. The net answer is $300 positive, right? This project is generating cash. It's profitable. The money coming in is bigger than the money going out. That's the sum of all cash flows, but that's without any discounting. We haven't accounted for the fact that we have to wait a year to get the $1,500 and wait 2 years to get the $1,800. So it doesn't take account of the time value of money. Remember, to use money, you have to pay. There's a cost of capital. So what do we have to pay? Well, in this case, we assume we have to pay 15% as the discount rate. That is the cost of capital in this example. So when we look at it that way, we take what comes in year one, right, $1,500, and divide it by 1 plus the interest rate, which is 0.15, 15%, to the first power, because it's in the first year. That comes out to be $1,304. In year two, the $1,800 would be, for the present value, $1,800 divided by 1.15, that's 1 plus the interest rate of 15%, right, to the second power, squared. That number comes out to be $1,361. So now the money coming in, expected in present value at 15%, is less than the $3,000 by $334. So suddenly it doesn't look like such a good project, right? We need to adjust the cash flows for the time value of money by discounting them back to the present value. We take that $1,500 and discount it one period at 15%, and we get $1,304.35 to be exact. Then we take that $1,800 and discount it 2 periods at 15%, and we get $1,361.06. Now when we sum those present values together with all those cash flows, we get a minus $334.59, which tells us that the project destroys value. It's not worth doing. It's a profitable project, but we don't want to do it. Why would we ever not want to do a project that's profitable? It all comes down to the 15% discount rate. That 15% indicates what the hurdle rate is for the profitability of the project. This project might be profitable, but it's not profitable enough to justify the required 15% return. If our investors require a 15% return to take the risk of this project, we're not going to be able to deliver it to them with a project like this. We can't deliver that kind of return. So let's examine some of the main drivers in the present value calculation. First is cash flow. Obviously, more cash is better than less. The second is timing. The further the cash flow is out in the future, the deeper it gets discounted. The third driver is the discount rate. The higher the discount rate, the deeper the cash flows get discounted, and the lower the NPV. The lower the discount rate, the less discounting, and the better the project looks. Lower discount rates, higher NPV. Higher discount rates, lower NPV. Net present value is the benchmark metric. It is our best capital budgeting tool. It incorporates the timing of cash flows. It incorporates the opportunity cost because that discount rate quantifies, in essence, what else we could do with that money. The fact that we're discounting implicitly incorporates the opportunity cost, and it incorporates risk. If we think the project is a lot riskier, what can we do? We can increase the discount rate to reflect that risk. NPV is objective in the sense that if we have good forecasting and good discount rates, accurate discount rates, we can lay this out and calculate it in a way that is presentable and explain it to anybody. It's an arm's length metric. NPV is transparent. We could sit down together with a spreadsheet and go over it and explain all the assumptions to each other. Net present value weighs the costs and benefits of cash coming in versus cash going out and gives us an objective, arm's length, and transparent metric for capital budgeting. It's a great tool. So let's remember, the main drivers of NPV are cash flow. More cash is better than less. The timing, the further out the cash flow is out in the future, the deeper it gets discounted, and the discount rate. The higher the discount rate, the deeper the cash flows get discounted, and the lower the NPV. The lower the discount rate, the less discounting, the better the project. Remember, lower discount rates, higher NPV. Higher discount rates, lower NPV.